Namastey Coders, I hope you're fine, doing well in your life. So mm, now we are gonna solve the LeetCode 75 problem, the second problem from prefix sum. So we have already solved the first problem from all the topics. Now we will start with the second problem, and we have solved the second problem of arrays, two pointers, sliding window. If you want, you can go through those videos as well. Let's start with the second problem of prefix sum. So before starting the problem, I will let you know that we have started LeetCode 75 a video series in which we will solve all the problems from LeetCode 75. Along with this, we have also started the LeetCode problem of the day series in which we are solving LeetCode problem of the day daily and uploading the video on my YouTube channel. So I have given the playlist link of the playlist in the description box. Also, I have created a WhatsApp group. The link is given in the description box. The purpose of the group is we can discuss multiple things there. Like we can discuss any doubt, any problem, or any algorithm. We can discuss the multiple approaches of any question. Along with this, that is the community of a coder, right? So we can start some good projects. We can discuss some good ideas as well. So if we can create a good project together, that will be really very helpful for our resumes. We can also do some freelance work there. So there are lots of use cases of a community, right? So I suggest you all to join that group and let's interact with each other. So let's start with the problem. So problem is find the pivot index. So we have a rule of solving any problem. So what we'll do, we have 3 steps. So we will first discuss the details of every problem in a depth. The details including what is given to us and what is expected from the problem and what is the other details, right? So if necessary, we will also discuss the constraints. So then we will try to solve the problem in the native approach. We will discuss the native approach in a depth so that we can grab the understanding of that problem. Then we will try to solve the problem in the most optimized approach. So that is also a structure of any coding, any interview. So let's start with the problem. So we have given array nums, right? What we need to do, we have to calculate the pivot index. So the pivot index is the index where the sum of all the numbers is strictly to the left of the index is equals to the sum of them. So okay, so we have given a number nums. What we have to do, we have to find the pivot index. The pivot index is the index in which the sum of all the arrays from the left of this pivot index should be equal to the all the arrays which is in the right of this array. So 5 and 6 will become 11 and 7 plus 3 plus 1 will become 11. So 6 is the pivot index. So 6 means index 3 is the pivot index. So answer is 3 here. In this there is no pivot index because as you can see, as we are at 2, the sum will become 1 and 3 which is not equal if we are at 3. So the right will become 0 and left will become 3. So that is not a possible case. So we will return -1. So this is the detail. I hope you got some idea how to solve this problem in the most optimized way. Don't worry if you haven't stuck with that idea, but we will discuss the native approach. So that will help you to understand your building your understanding of these type of problems, right? So how can we solve this problem? So in the native approach, what we can do, we can iterate through each array. So let's say we have 1, 7, 3, 6, 5 and 6, right? So what we'll do, we'll iterate through each index and we can calculate the sum of that index. We can calculate the sum of left elements and right elements, and we will check if the sum is equal or not, right? So for 1, the sum to the left is 0, but the sum to the right is is can calculate. This is 10 and 21 and 27. So answer is 27. Now we will go, so the 0 is not equals to 27, so we will iterate again to the right. So we have at 7. So the sum of all the left element will become 1 and the right element will become, we have to calculate again for this approach. But what we can do, we have calculated this, right? So we will subtract 7 from this. So okay, leave it. We have 9 plus 5 14 plus 6 20, right? So yeah, 20. And how can we get 20? How can we get 20, right? We can subtract 7 from 27. So that is our optimized approach, right? So as you can see, guys, while discussing the native approach, we got idea of solving this problem in a very optimized way. So in the native approach, what is the time complexity? So let's say we are at 3, so we have to iterate through left and we have to iterate through right again and again. So the time complexity will become n square, right? Because we have to iterate through all the elements, and while iterating any element, we have to iterate through the all array again. So n square. But you got some idea how to reduce this time complexity to n. So that is the required time complexity as well. So if you have got the idea, congrats. I mean, you are on the right path. If you haven't got the idea, I suggest you to take a pause and think about this problem again. Okay, if you haven't like got some idea, so it's okay, no worries. Give some time. So you will have some practice. If you have some practice, you will also start solving this problem very well, right? So let's discuss with the most optimized way. So what we will do, we will make 2 counters, right? First left counter, second right counter. We will initialize left counter with 0 and we will initialize right counter with the sum of array. So sum of array, so for this sum of array will become 28. So 28 is the sum of this array. Now if we are iterating through any element, right? So we will if we are iterating through any element, let's say we are iterating as element 0, we will decrease that number from this right counter. So the right counter will become 27 and we will increase the previous. So we will also make a previous equals to 0 initially. So we will increase the previous in the left counter. So left counter will still be 0 and we will check if left counter is equals to right counter. The left counter means the sum of the element in the left and right counter means the sum of the element in the right. So let's say we are at 1, the left counter is 0, right counter is 27, right? So we will iterate, we will shift right and we are at 7 right now. So the previous, so while shifting, before shifting, we will make previous as the current element. So previous is become 1. Left counter will be added with the previous. So previous is nothing but the previous element. We can also use the I minus 1 element, but anyways, and we will decrease the current element from this right counter. So this will become 20. Again, 1 is not equals to 20, so we will again iterate again. So we are at 3. So previous will become 7 from the previous iteration. So left counter will become 1 plus 7 is equals to 8. Previous will become 3 here and 20 will be reduced by 3, which is 17. Now we are at 6. Previous is 3. 8 will become 11 because 3 will become 6 and the 17 will become 17 minus 6, which is 11. Now left counter and right counter is equal, so we will return the I is nothing but 3. I is the index and the answer is 3. So this is the straightforward approach for solving this problem in O n time complexity. So let's code this. So left counter is nothing but 0, right counter is sum of nums, right? So for I in range, length of nums, right, left. So previous is nothing but 0, left counter will be added with the previous will become nums I, and the right counter will be subtracted with the nums I. And if left counter equals to right counter, return I, otherwise if we haven't got a index from this loop, we will return -1, right? That means there is no possible solution for this case. So that's all we need to do. Yeah, we have solved this problem. Let's submit this. Yeah, we got a maximum time complexity, so we have solved the problem in the best possible case. So that's all from my side, guys, in this solution. Again, I suggest you to go through all the videos for LeetCode 75 as well as all the previous LeetCode problem of the days. Also, if you want, you can join the WhatsApp group, which will be very helpful for you as well as all of us. So thank you for your time. Thank you.